Hi everyone. Here is another question involving equations involving indices. We have 27 raised to the power x minus 3 raised to the power x is equal to 80 multiplied to 3 raised to the power x. How do we solve for the value of x? Okay, so if we look at it, we see this one is already in the simplest form, but 27 to the power x can be further simplified by changing 27 to an index number whose base is 3. We all know that 27 is solution. We all know that 27 is 3 cubed, but 27 was raised to the power x. Okay, so this one becomes 3 to the 3x. All right. What we see is that we have an expression in terms of 3 to the power x. This one actually can be also be written as 3 to the x cubed. So that we see clearly that it is an expression in terms of 3 to the power x. So let us take this one to the left hand side. So we have 3 to the x cubed minus 3 to the x, bringing this one this way, minus 83 to the x is equal to 0. Right. So here we have 3 to the x, 3 to the x. We can factorize it out here. Into 1 plus 80. All right, because if we open this parenthesis, we're going to get this expression up there. Negative 3x multiplied to 1. Negative 3 to the x multiplied to 1 is negative 3 to the x. Negative 3 to the x multiplied to this 80 is going to be negative 80 times 3 to the x. All right, so this gives us 3 to the x cubed minus 81 3 to the x is equal to 0. At this point, we see a cubic expression in terms of 3 to the x. To make it look clearly, we can make the substitution y equals 3 to the x. So that when we put it there, we can see clearly that it is actually y cubed minus 81y is equal to 0. All right, if we take our factorization process, y is common. So we have y into y squared minus 81 is equal to 0. This therefore means that either y is equal to 0, either this is equal to 0, or y squared minus 81 is equal to 0. This one here we see is a difference of squares. It is y squared minus 9 squared equal to 0. And we know the identity of difference of squares. It is y minus 9, y plus 9 equal to 0. This product giving us 0 means either y minus 9 is equal to 0, in which case it therefore means that y is equal to 9, or y plus 9 equals 0, which therefore means that y is equal to negative 9. All right, so here we have the two values for y. But remember, we were not asked to solve for y. We were asked to solve for x. How then do we bring in x, or how do we get the x, knowing the values of y? We have to go back to this substitution that we made. This substitution that we made will help us find the values for x. Okay, so if we take the substitution, y equals 3 to the x, then we will solve each of these situations. First, we take y equals 0. If we have 0, if y equals 0, we have 0 equals 3 to the x, which is simply impossible. Okay? There is no index expression that will give us 0, no matter the nature of the power. There is no index expression that will give us the value 0. Therefore, the result y equals to 0 is rejected. If we take the next, y equals 9, 9 is the same as 3 squared. So we end up seeing this index expression equal to this index expression. The base here is 3, the base here is 3. Automatically, since the bases are equal, automatically the powers should also be equal. And so the value of x is 2. And then the last one, negative 9 equals 3 to the x is also impossible because there's no index expression whose base is positive that will give us a negative value. There is no index expression whose base is positive that will give us a negative value. Hence, this other value for y is excluded. This one is excluded, and this is the only right value for y. And this right value for y has given us the only right value for x, which is 2. Okay?